This is Chapter 2-1, Conditional Statements. Please copy your cuts, hit pause so you can do so. To begin, we're going to start with some definitions. First of all, in this chapter, in this section, and the next couple of sections, with conditional statements, I need you to think really big. It's going to require some thought processing and some time. To begin, conditional statements have two parts that are written in the if-then form. And again, I can't stress enough that conditional statements are going to require you some logic, some thinking, some processing. But again, conditional statements are statements that have two parts. The first part is the if, the second part is the then. Here's the first part, the hypothesis. Just like in science, you have a hypothesis. In math, for conditional statements, the hypothesis is the if something occurs or if something happens. The second part on a conditional statement is the then portion, okay, or the conclusion. So the conclusion is the part that we consider then. An effect happens. If you do this, then that will happen. If you do not do your homework, then you may get a lower score. If and then, the hypothesis, if something happens, if you don't do your homework, then the conclusion, the effect of not doing your homework, low score or no score. Okay, here's an example. Referring to your book, you can look at chapter 2:1, but this example states, if it is noon in Georgia, then it is 9 a.m. in California. We can immediately tell which is the hypothesis because of the if. It is noon in Georgia is the hypothesis. The then portion gives us the idea that this is the conclusion. The conclusion is, it is 9 a.m. in California. It is 9 a.m. in California. Okay. We rewrite if-then statements. Here we go. We have this example. 2 points are collinear if they lie on the same line. How will we rewrite this in the conditional statement format? You can take a pause and try that if you like. Otherwise, here's the answer. If 2 points lie on the same line, comma, which should be there, then they are collinear. And again, you should remember collinear from chapter 1, points that are on the same line. Okay, so there's the example. And now we write it in the if-then statement or as a conditional statement. Here's another one. You can try this one here. All sharks have a boneless skeleton. So there's no if or then in this one to give you a clue. How can we write this as a conditional statement? You can hit pause to solve it. Otherwise, here's the answer. If a fish is a shark, comma, then it has a boneless skeleton. So again, the hypothesis, a fish is a shark. The conclusion, it has a boneless skeleton. Okay? And finally, if you'd like to try C, dealing with math, a number divisible by 9 is also divisible by 3. You have to be careful with this one because one rule will be true and the other way you write it will be false. Okay? Here's the answer. If a number is divisible by 9, then it is divisible by 3. We could not have written this the other way to say if a number is divisible by 3, then it is divisible by 9 because all numbers that are divisible by 3 are not divisible by 9. For example, 15. We write if a number is divisible by 3, example 15, then it's divisible by 9. That's false. So we would have to be careful and make sure that the if part, if a number is divisible by 9, then it's also going to be divisible by 3. Now, here's the thing. You want to make sure you look for key words to tell you what the hypothesis is and what the conclusion is going to be. Okay? If is a dead giveaway that that's going to be your hypothesis, the then your conclusion. And in some cases, and like in C, you have to be careful and make sure you know what's going to be true and what's going to be false. We had to write the 9 first as the hypothesis, and then the 3 is the conclusion. Because if we write it the other way around, as I stated, if a number is divisible by 3, then it's divisible by 9, it's false. Because as I stated, okay, 15 is divisible by 3 if that had been 3, but it is not divisible by 9. So we have to be careful. But look for keywords, test it out, and if something comes out false, then you know it goes the other way around. Next statement. Conditional statements can either be true or false, either true or false. To show a conditional statement is true, the conclusion must be true for everything in the hypothesis. To show that a conditional statement is false, like we did in chapter 1, you have to show at least one counterexample. Remember, counterexample is proving that it's not true, or in other words, that it's false. Okay? All right, we can write the counterexample for the following statement. If x squared is equal to 16, then x is equal to 4. We need a counterexample, or in other words, prove that this is false. Here's a false statement. Counterexample says x is equal to negative 4. Because if I put in negative 4 here, negative 4 squared still is 16. So that means that x is not always 4. This is a counterexample making this conditional statement false. Okay? Now, looking here, the hypothesis is still true. That's true. Okay, this first part, x squared does equal 16, but the conclusion is false. So that means that the conditional statement, the entire thing is false because both do not agree. Although the first is true, the second is false, that means the entire statement will be false. Everything is going to be false. Provide a counterexample for the following. You can hit pause after you get this. If a number is divisible by 2, then it is divisible by 4. Hit pause. Otherwise, the answer for a counterexample would be 14. 14 would be a counterexample because 14 is divisible by 2, but it is not divisible by 4. So there's your counterexample. Converse statements. A converse statement is simply when I take the hypothesis and the conclusion and I decide to switch them. I now make the conclusion the hypothesis and the hypothesis the conclusion. This is called a converse statement. For example, if this is my original conditional statement, if you see lightning, comma, notice the comma, then you hear thunder. That's the original conditional statement. The converse says now that I have to switch the hypothesis for the conclusion and the conclusion for the hypothesis. So here is my hypothesis. It needs to go to the back here. And then I see my conclusion, which needs to now become my hypothesis. So let's write the converse to this original conditional statement. Here's the converse. If you hear thunder, notice that the conclusion is now the hypothesis, comma, then you see lightning. The two have been now switched, making this a converse statement. You can try it. If I give you this original statement, if two segments are congruent, comma, then they have the same length. You can hit pause and write the converse statement. Otherwise, here's the answer. If two segments have the same length, then they are congruent. All right? Now, let's look at negation. So we have the original conditional statement. We just learned about the converse. Converse again, when I switch the hypothesis and conclusion. Negation is when I have my original sentence and I make it negative by putting the word not. So for example, here's my original statement. Let's say my original conditional statement says, if the measure of angle A is equal to 30 degrees, then angle A is acute. I get a negation if I use the word not. So negation is using the word not. So my original statement, now my negation, because I use the word not. If the measure of angle A, I no longer say equals, I say it's not equal to 30 degrees, then angle A is not acute. So the two nots in the hypothesis and the conclusion make this a negation. The minute I have an original statement and I put a not in there, it becomes negated. Now, inverse statement. So we've talked about two things still. The original statement, we talked about a converse. Remember, converse is when I switch the hypothesis and the conclusion. I talked about a negation, so this will be a third thing which we're going to get further into, is when I use the original statement, but I put the word not in there. An inverse statement is when I take my original, whatever my original statement is, and use negation to rewrite the conditional statement. It's the opposite of the original. So now when I use the word not, I don't call it negation. It is negation, that's what you're doing, you're negating it. But when I use the word not, I now call that's an inverse statement. Okay? And it's going to be opposite of the original statement that you have. For example, going back to my measure of angle A. If this is my original statement, it will read, if the measure of angle A is 30 degrees, then angle A is acute. That's original. If I write the inverse, remember, for inverse, I have to use negation, or in other words, I have to use the word not. And when I use the word not in there, that's going to be called an inverse statement. So here's my inverse statement based on the original. If the measure of angle A is not equal to 30 degrees, not equal to 30 degrees, then angle A is not acute. So this is called an inverse statement when I use the not. Okay, not means I'm negating it. Here you go. You can write the converse we just did back on the last slide. I can write a converse statement based on the original. Remember, converse means I'm switching the hypothesis and the conclusion around. So if the original is if the measure of angle A is 30 degrees, then angle A is acute. The converse means I'm going to switch the hypothesis and move it to the conclusion. Let's look. So here I have, if angle A is acute, notice how I switch, then the measure of angle A is 30 degrees. So converse, I'm going to switch the hypothesis and conclusion. Now I'm doing three things. I have an original sentence. I have an inverse when I leave the original sentence like it is, but I just put the word not in there. The converse says everything's based off the original statement. So converse is I'm using the original sentence or statement, but now I switch the hypothesis and the conclusion. Contra statement is the last, fourth and final statement. A contrapositive statement is when I use both the converse and inverse to write a conditional statement. So I got to do inverse and converse together. Okay, we're going to try it. Here's a contrapositive statement. Okay, first of all, if I look back here, I know I need the inverse statement. So that means that I need the measure of angle A. It's still written with the hypothesis is first, and then the conclusion is second. But in addition to that, I have to now also switch around the hypothesis and conclusion. So I'm going to use the hypothesis and conclusion. I've done the inverse with the not. Now I'm going to move this to the back and make it the hypothesis and make the hypothesis angle A is not acute. It's going to go to the front. So the contrapositive should read, if the measure of angle A is not acute, then the measure of angle A is not 30 degrees, because I'm using inverse and converse at the same time. I have to switch the hypothesis and conclusion, and once they're switched, I have to use the word not, two at one time. So here's the contrapositive, Again, if angle A is not acute, then the measure of angle A is not equal to 30 degrees. I did 2 for the price of 1. Remember, is acute was the originally from the invert. It was up here at the top. For our converse, it was switched around. So now here's my converse. Acute is down here. I've also included the negation or the inverse and put the not. So I'm doing 2 things when I do contrapositive. I'm going to switch the hypothesis and conclusion, and at the same time, I'm going to use the not or the negation. So 2 things contrapositive does. You have to switch and do the opposite. Or I'll just put switch rather. I like switch. Switch the hypothesis and conclusion. And then I also have to do number 2. I have to do negation or do the not. Alright. What's equivalent? Equivalent statements when 2 statements are both agree. These are the 2 that should always agree. The original statement and the contrapositive should both mean the same exact thing. The other 2 that should always be the same. The inverse statement and the converse statement should always mean the same thing. Both will be false. Let's go back again. Original statement and contrapositive statements are both going to be true. And then the inverse and converse are the same, and both of those will be false. Okay? You can hit pause and try this is the last thing here. What you're going to do is take this original statement. If an animal is a fish, then it can swim. Write all 4. First of all, you have the original statement. Write the 3. Write the inverse for this statement. Write the converse for this statement. And write the contrapositive for this original statement. Here are the answers if you didn't hit pause. Inverse, remember, inverse is using the not. If an animal is not a fish, then it cannot swim. Okay? What does the converse say? Converse means just switch the hypothesis for the conclusion and the conclusion for the hypothesis. So if an animal can swim, then it is a fish. And remember, the contrapositive means I use both the inverse and the converse. Okay? So I've already switched. I like to start with the converse when I do this. That means I've already switched the hypothesis and conclusion. If an animal, and it should be cannot swim, then it is not a fish. And there it is there. And this is your lesson 2.1.